All right, we're going to take a look at the labs for Module 5. Labs 9 is going to be 9.0 and 9.1, specifically starting with exercise 12, which again you can find in your lab manual starting on page 65. So let's go ahead and talk about temperature patterns. This is going to be a minor recap. We talked about this in Module 4 a little bit, so it's more or less a test to see how much you learned. When discussing Earth's temperature patterns, we had previously talked about the amount of insolation that is coming into Earth's atmosphere directly from the sun. And we talked about previously we talked about three different things that kind of impact the temperature patterns that we experience or we can see across the globe. We talked about latitude, the land-water contrasts, right? That's that continentality, as well as altitude. And so we're going to recap that a little bit and add two more components to it that you'll need to be aware of in order to complete exercise 12. Those two would be ocean currents and wind patterns. So comparing these maps, hopefully you're familiar with these. We are looking at the temperature patterns that exist during winter in the northern and southern hemispheres, right? Comparing winter versus summer and taking a look at those temperature patterns and what happens to impact those patterns. And we previously talked about latitude and how when we compare two different areas that share a same latitude, in an ideal world where there's no other factor impacting temperature patterns, you would expect that the locations that share a latitude would be or have and experience similar temperatures. So one of the big things that impacts that, aside from altitude, right? But that's that land-water contrast. That's what we talked about, the continentality, where if we are on a land mass during January or a winter month versus July, a summer month, if we're talking about the northern hemisphere, you can see how the average temperature, if we're staying on the same latitude, right, in the northern hemisphere, how over an ocean, it is going to have much smaller impacts as to how low or how high that temperature is going to change. And so keep that in mind because that's what we had talked about in the previous lab. So figure 12.1, again, is available in your lab manual, page 66, with a bunch of additional supplemental reading that you definitely want to read through in order to best prepare for this lab. Not only will exercise 12 cover the latitude, the land-water contrasts, and altitude, but it's also going to introduce ocean currents and wind patterns. Coming straight out of your lab manual, ocean currents, the general circulation of the ocean is a significant mechanism of global heat transfer. Major surface ocean currents move warm water from the equatorial regions towards the poles and bring cool water from the poles back towards the equator. In each of the main ocean basins, right, so that an ocean basin is going to be this area between major continents. Between the major ocean basins, warm water moves towards the poles off the east coast of continents, while cool water is moving towards the equator off of the west coast of continents. So if you look at this pattern, you can see how around the equator, where we know that we have high insolation, generally water is going to be warm here. And due to something that we have not talked about yet, the Coriolis force, that is going to help indicate which directions these ocean currents are going to be spinning. But you'll notice that everything in the northern hemisphere is generally moving from the right side to the left side, so it's going from east to west, and it's bringing with it these warm currents, and it's going to be moving north along the eastern coasts of the continents, and as that goes up, cooler water is going to be coming and drifting back down along the west coast of continents. And so you can see this pattern, warm water comes north, cooler waters move south. Or reverse, you can see that the warm water is going towards the southern hemisphere, so that's why we say poleward. Warm ocean currents are moving poleward, warm ocean currents moving poleward, meaning that the cooler ocean currents are moving towards the equator. And so in each of these various ocean basins, you can see that that general pattern exists everywhere. And just like ocean currents, wind patterns in the majority of the world have a dominant wind direction. And similar to the ocean currents, this is also impacted by that Coriolis effect or the Coriolis force, which again, we haven't really talked about. But again, for example, this is coming straight out of your lab manual, in the mid-latitudes, the dominant wind direction is from west, meaning air masses will tend to move from west to east. As a consequence, the temperature patterns of mid-latitude locations along the east coast of continents can be quite continental. The westerlies, again, these are winds moving westward or coming out of the west, can bring the seasonal warmth of coldness of the interior of the continent all the way to the east coast. The general movement of the wind is going to be from the west moving towards the east. So, in general, ocean currents and prevailing wind direction or wind patterns are also going to impact the temperature patterns that we see all over the world. So keep that in mind when not only answering the questions that you need to look at for your practice exam, for your practice lab, you need to read through all of the reading in exercise 12 in order to answer these questions. And once you have that, you're going to be able to move on to the graded portion of this lab, where you're going to have to identify differences between the cities and the information expressed in these charts. So again, this is coming straight out of your lab manual, but you can see that there are 6 charts. There are 6 charts showing the average monthly temperatures in both Celsius and Fahrenheit for 7 US cities. And so again, just to point out that the 7, or city 6 and city 7, is shown here on this chart together, as they are both cities in Hawaii. Using the first letter of every month shows us that we are dealing with 12 months, showing us the average annual temperature changes. And so you need to use your knowledge to basically decide what is causing these temperature patterns. And you will have to look these cities up on a global map. And so for those of you that may not have an atlas where all of these cities are going to pop up, you should definitely use Google Maps. Just, popping in the city on Google Maps will show you whether it's coastal, where its latitude is, and then deciphering what its temperature patterns are, as well as its altitude or its elevation, should help to indicate to you what type of weather pattern this or these cities are experiencing. And so based off that, you are going to have to decipher what the most impactful component is influencing these cities' temperatures, or I should say these cities' temperature patterns. So that's what you need to do for the graded lab. And you have been asked also to take a look, and this is in the back of your lab manual, it's in the appendix, appendix image T28. So again, pay attention to and look at this when you are analyzing or trying to understand the weather patterns that exist across the globe. Keep in mind the winter versus summer influences, again, the influences of ocean. And now that you know how ocean currents move, maybe you'll see certain patterns along certain continental coasts that might change from winter or summer, as well as paying attention to where we see large and small annual changes in temperature. So use all of this to work through exercise 12, both the practice and the graded labs. And then once you're done with that, obviously go ahead and work on the next exercise, exercise 13. Let me know if you have any questions. Thanks.